So, hello again. I am Alessio Radice, and I am one of the teachers in this CERME program. I have been asked to provide you with some presentation of the program in the next hour, basically. We are supposed to have a presentation first and then a question time. Anyway, we are not many people connected now because I see you are 24 participants. Therefore, if you think that you have questions in the middle of the presentation, feel free to ask. I will use a slideshow, so now let me go to connecting to sharing my screen. Okay, as you know, this open day with presentation of the Master of Science programs took place in 2 days, because yesterday there was a presentation for the students coming from the Politecnico, and today there is a presentation for students coming from other universities in Italy and abroad. So just a few words of introduction. If you are interested in this program or in other programs of the Politecnico, you probably know the university. Anyway, we are in northern Italy, around Milan, and something you may have seen from our website is we have a few campuses around northern Italy, as depicted in this picture. We have 2 main campuses in Milan. That is where the first campus of the Politecnico di Milano was founded, and some other campuses in surrounding towns. What we are talking about today is the CERME program that is based in Lecco. So here, consider that just for a quick information, between Milan and Lecco we have some 50 kilometers, 1 hour commuting time, a bit less, but let's say 1 hour commuting time. I have put here some numbers that are taken from the website of the Politecnico, and therefore they are also known to you. It's a relatively small university because we have less than 50,000 students. It becomes a big university if we consider the disciplines that are taught, in the sense that we have these 50,000 students entirely devoted to engineering, architecture and industrial design, which is quite a large number, because in universities covering a wider range of disciplines have many more students, but of course they teach a lot of stuff, and therefore the number of students in engineering or architecture, for example, is much less than ours. Our percentage of foreign students is quite significant. They are mostly at the Master of Science, and this is basically related to the fact that our bachelor is in Italian, while the Master of Science is mostly in English. Almost all our Master of Sciences are taught in English. That is, of course, what stimulates the interest of foreign people. Consider that, as you see here, we have 41 programs of Laurea Magistrale, that is the Master of Science, that are taught in English. I think the total number of Master of Science programs is 43 or 45. Therefore, you understand, they can be accessed, almost all of them can be accessed by every people. We claim to be a good university. That is also probably the reason why you are interested in it. And okay, you can give to rankings the value you want, but in general, in international rankings, the Politecnico di Milano is placed well. Now let's go and talk to this program of civil engineering for risk mitigation. It's one of the programs entirely taught in English. Actually, in the campuses that are out of the main city, out of Milan, teaching in English is something that started quite a long time ago, some 15 years ago, while it started later in the main campuses. The Civil Engineering for Risk Mitigation program exists since 2010, so it's more or less 10 years now. And it has been always attended by a significant percentage of international students. Consider that the percentage of foreign guys that we have in our classes is more than 70%, while the average of the Politecnico is around 20 or less. This has been mostly due to the long time for which this program has been taught, basically. However, let's now talk a bit about it. It's a course of civil engineering with a specific focus on risk mitigation, as you see described in this slide. The Politecnico offers two courses of civil engineering. One is called Civil Engineering. One is called Civil Engineering for Risk Mitigation because it tries to give an outlook from civil engineering to the area of natural and anthropic risks and mitigation strategies. So it intends to be less general and has chosen this as a focus. Why? Because well, we have to face as engineers problems related to natural or anthropic risks. Here I put just a few pictures to mention which the risks that we most typically consider are. So, for example, you see on the top left the effects of an earthquake, on the top right a fallen bridge. This is something that happened a few years ago close to the Politecnico. This bridge has fallen because there was an exceptional load from a truck that transported steel. The bridge fell with all the negative consequences that you can imagine. Then we have landslides, as you see in the bottom left picture, or floods, as you see in the last picture. These are the phenomena that we most typically consider, and the idea is these things happen. We need somebody able to face them, where face means prevention or means managing emergencies if they happen. And therefore, these are the considerations that time ago stimulated the creation of the CERN program. The Master of Science is articulated along 2 years. There is quite a difference in the perspective that we follow in the first and in the second one. This is because the first year comprehends some courses with their exams, obviously, and the idea is that all these courses are going to teach you something in any discipline. The second year, we like to say that is not organized along these courses, but is organized along these modules. What is a module? A module is in the end a group of courses, an integrated course that takes quite a lot of credits, as we will see later. And the idea is that these are not courses in which you are taught some discipline, but the perspective is there is some problem at stake, there is some hazard or some risk, and there is some work to be done to manage it or to mitigate it. By definition, these modules are interdisciplinary because in order to solve or mitigate a certain problem, different skills may be needed. And therefore, typically these integrated courses are also taught by people coming from different disciplines. We are going to enter into more detail about this later. So here is the table of the first year. 1 year is 60 credits. There are, as you see, courses framed in different disciplines. So, for example, this course of soil structure interaction that is basically in the area of geotechnics, hydrology and river hydraulics that are courses in the area of surface flows, computational mechanics, structural dynamics, theory of plasticity that are courses related to the solid mechanics, to the mechanics of solids and structures. So you see here the perspective is to teach some disciplinary content. Then we have 3 courses that I left for the end because they are, of course, framed in one discipline, but we consider them as tools of general use. So, for example, we have a course of numerical analysis, as you see here, that teaches fundamentals that are used in any of the others. A course of GIS, so geographic systems, that are also tools that can be employed in the analysis of different phenomena. And characterizing the first year of the program, there is also this course of tools for risk management that is basically an introduction to the risk mitigation aspects that are the focus of the study program. So, as I was saying before, all these courses are organized in terms of there are some lectures, there will be some application classes, there will be some knowledge acquired. When we pass from the first year to the second year, sorry, here there is a mistake that I spotted yesterday, but I haven't fixed yet. When we pass to the second year, we have these modules. As you see, the modules are 16 credits each. 1 year is 60 credits, and therefore the idea is that in the second year of the program, a student will attend 3 of these modules, and then we'll have a final project, a final thesis that will correspond to 12 credits. We offer 6 of these modules. As you see, 3 on the first semester and 3 on the second semester. The idea is that a student will choose 3 of them. As you see, I use the different colors in this slide because basically we consider that we have 2 tracks, one that is more related to structural and infrastructural risk, one that is more related to hydrogeologic processes, and we consider that 3 of these modules are more related with the hydrogeological risk and 3 of them are more related with the other track. What a student can do is to choose, in the end, any combination of these 6 modules. So there is total freedom of choice. However, the color that is chosen more will label the study plan. So, for example, if a student takes 2 blue modules and 1 red one, the plan will be CERM hydrogeological risk. If vice versa, the student chooses 2 red modules and the blue module, the plan is going to be labeled CERM structural risk. It is a minor impact because in the end this choice will appear nowhere. Anyway, we propose the table of the modules in this way to clarify that in principle there may be 2 areas on which a student can concentrate by an appropriate choice of his or her study plan. To give you an idea of what this means, of what these titles mean, we have a short description of all the modules of the second year. The first one is the one called Structural Retrofitting. Here we are considering structures that are exposed to the action of different triggering agents that are the earthquake on the one hand, fire and blasts on the other hand. And the idea is to analyze the bearing capacity of the structure, possibly designing some retrofitting, in case this is possible, of course, because if a structure is entirely destroyed, this is impossible. And they also focus on the possibility to design prevention measures against these loads. I take this slide to clarify the structure of these modules. They are typically taught by a group of people. In this case, they are 2 people, as you see, and the 16 credits of the module are split into 10 and 6. Other modules, as we will see later, will be divided into even 3 single courses. So this one was retrofitting. This is the GPM module that again focuses on seismic emergencies, so earthquakes, but with a different perspective, because in the previous one we were talking about structural design or structural retrofitting to face the effects, for example, of earthquakes. In this case, we are instead talking about non-structural mitigation, that is crisis management. Here the idea is that when you have any type of crisis, you need to handle it. Basically, you need to know which actions should be performed. And choices, decisions must be supported by data. Data must come in a suitable manner, because if they are not understandable, if they are not useful, you cannot steer your actions. And therefore, for example, this module is related with how do we represent a hazard, taking the example of an earthquake, in order to steer the management actions. Again, as you see, this is quite an interdisciplinary module, and therefore there are 3 teachers, and the subdivision of the 16 credits is 5 plus 5 plus 6. Then we have a module related to transport networks in relation to the risks to which transport networks are prone, in relation to the fact that, again, when there is a crisis that needs to be managed, quite a lot of this management passes through the transportation network, because it's our communication. And therefore, these are the aspects that are considered here. So now we have seen the 3 modules that are included in the line that we call structural and infrastructural risk. You see, it's not a matter of concrete design, it's not a matter of GIS, it's a matter of having some problem to be faced and integrating different competencies in order to try to solve it. Okay, that was what I initially declared as the characteristic feature of the second year of this program. Passing to the second part that is related to the hydrogeological risk, we again have 3 modules. The first one is this GetUs that is related with unstable slopes. It is mostly devoted to monitoring. Therefore, the idea is, okay, let's suppose you have an unstable slope. How can you monitor its behavior? Possibly designing thresholds for giving alerts. For example, if this unstable slope is expected to move significantly. What you see in the picture is a laboratory installation in which an unstable slope is created by tilting some volume of earth. Sorry. And you see they are performing some monitoring campaigns. So, for example, you see the total station here. The idea is that knowledge and monitoring tools are necessary in order to know which situations can be more troubling than others. Here they talk about geological assessment, photogrammetric assessment, geophysical assessment. And we have so on the one hand, we monitor the problem. On the other hand, we need to find solutions. We have a module of engineering structures that is basically, given that there are unstable slopes, as monitored in the previous slide, let's say, how can we design structure for mitigating these risks? And therefore, for example, here you see stabilizing piles. Here you see structures. I don't remember the English word for this. Anyway, stabilizing structures over a slope. This is a field lab that we have close to the university. So on the one hand, there is a demand for risk mitigation because you have monitored an unstable slope. On the other hand, there is the design of structures that are suitable to mitigate it. Then here they also consider the fact that since you build something that will be typically underground, there is an important aspect of corrosion on the one hand, or durability of these structures that are exposed to weathering actions, and therefore here students also study the corrosion and protection issues. And this is the last one that is also related to the hydrogeological risk. It is basically considered that all these hydrogeologic processes can threat the surroundings. For example, here you see a flood map of a mountain town where the inundation was determined by heavy rains combined with hydrogeologic instabilities. Here the idea is not of mitigating this problem building some structures, but is mitigating this problem by appropriate planning, and in this case we are talking about emergency plans. So basically this quick overview on what is included in the modules of the second year gives you an idea of which the typical problems that one can encounter in the classes of this course are. Why were they chosen? They were chosen on the one hand because they are important, they are significant for the area where we are, but also for others. And secondly, they were chosen because we have teachers in this university who research on these topics, and therefore they are able to bring their expertise and research in the classes. Of course, it would be extremely nice to have to include also different risks in the program, but then if the university has nobody who is able to teach them, it will be damaging students, of course. What we, well, this was mostly for the students of yesterday because they are deeply in the debate that is made presently at the Polytechnic about this innovative teaching, but the idea anyway is that we try to shift from what is called the deductive teaching to what is called the inductive teaching, that is a combination between a theory and hands-on approach that we think would be more beneficial to the students. Our starting point of everything I told you is September. So when I talk about the first semester, I am talking about the classes that start in September, and second semester is the classes that start in March. The ideal thing to be done is to enter the program in September, because this is the way. However, we also have many students who enter the program in March. What happens of everything I told you so far? A student who enters the program in March has to attend the first year, obviously. But then only the second part of the first year is available, because the first one has gone. Then what happens is that this student will create a study plan, including the exam of the second part of the second semester of the first year, and some exam of the second. And then of the next year, she or he will catch up. In general, this is common to all the courses, all the programs of the Politecnico. There are the study plans that we call already approved, because they perfectly fit our tables that suppose that the career starts in September. And then there are autonomous plans that are created in order to fix particular situations, and the typical one is the situation of students entering in March. In the end, when we arrive at graduation, what a student entering in March will have studied is exactly the same as what a student entering in September will have studied. But the timing is going to be different because there was a different entrance point along the year. We have people who are in charge of helping students design their study plans in case of particular situations. Then this is a side product in the end. We also have a specializing master that could be taken instead of the Master of Science. This lasts only 1 year. And of course, it picks some of the contents that I described previously. We consider important to include these exams of tools and fundamentals of GIS from the first year, then there will be 2 modules of the second year, and then a final project. And this is more or less all for the description of the study program. Sorry again, we are here, and honestly we are quite proud of our campus because it's the newest one of the Politecnico. These are the lecture rooms that you see here. This is the library, and this would be important for foreign students. Accommodation is relatively easy here. Consider also that this is the building of the lecture rooms, and this is the student residence. So in case one wants to live in the campus, this is possible. And well, it has all the benefits and shortcomings of a small campus. It has all the benefits of a new campus, because again, it's the newest one. Honestly, I wouldn't see any shortcoming of studying in a new campus. Other facilities are the labs. We have labs in this case. Years ago, you know, the Lecco campus was only a place for teaching and not for doing research. And due to this reason, it hadn't laboratories. Small laboratory facilities, but nothing big. With the construction of the new campus some years ago, also laboratories have been built, and here you see a list of some laboratories that are available in the campus. By the way, what you see behind me is a photograph of the hydraulics lab. It's just a photograph because I am not there now. How are these labs used? They support teaching activities. Some application classes are held in the labs. For some courses, just a few. For some courses, quite a lot of laboratory activity is included. And then, of course, they can be used by students for the final thesis if they wish to perform their final thesis in the lab. Well, we'll go quickly on this. I would say that our graduates are typically happy of having been with us. As I always say, these surveys are a bit biased, honestly, because when you send out a survey, the people who respond are those who have been most excited, and therefore they are always biased to the top, but this is true for any course. In general, as I mentioned at the beginning, the reputation of the Polytechnic is good, also because the satisfaction of the graduates is good. Okay, nothing to say about these slides. They are just names. In case you would need more information, there are people who can be more or less appropriate to answer your questions, and therefore, well, the structure of the university implies that every course, every program has a coordinator, and in principle, this is the first person to be addressed, and the coordinator is helped by a number of people. We have also, let's say, smaller scale coordinators that are the reference professors for the modules. As I told you before, any module is compounded by some different courses, and therefore it needs a coordination by itself. Here are the guys who are responsible for each module of the second year. Then we have people responsible for specific functions that are related to admitting students, to helping students design the study plans, to do student exchanges with abroad. About the student exchanges, let me say that the CHERM program is already a student exchange in the end for a guy who comes from abroad, and therefore typically a student is never allowed to spend 1 year out of Italy, because otherwise he wouldn't have been studying in Italy in the end. But still we have some international exchanges. As everywhere we have student representatives, so it's not very important to talk about it now. The Lecco campus, thanks to its size that is not very big, proposes a number of extracurricular activities that are not framed in a specific study program, but are given to all the students, are offered to all the students who attend the campus. How can a student be admitted to the program? Now we are talking about the rules for people who don't come from the Politecnico, and basically in the end there is a decision by an admission committee. This decision may also include some prescriptions for the study plan. In general, they are very limited, but if it's recognized that a student lacks a certain fundamental discipline, it may be added to the study plan. Or if it's recognized that the student is already strong in some discipline, it may be removed from the study plan. But this is extremely limited for the students who don't come from the Politecnico, because of course we see the titles of the subjects you have studied, but we don't really know what you have actually studied, and therefore it's quite risky to force the study plans in general. It is, as I said, extremely limited. Here you see some references. I think that you already know most of these links that are the typical places where information about the program is provided. With this, I have finished, and I can stop sharing my screen, and this is time for questions, if you have any. I hope I have been clear in my presentation. I hope that I have covered all the things that you would have liked to see included. I see a question in the chat. They told us that this semester will be in a blended mode. I see some question in the chat. So, due to COVID-19. So the first two questions are related to the health emergency that is presently ongoing. So what has happened in the last months? I know it's not the focus of the questions, but it's just to give a complete answer. So this semester that has just ended was provided completely online. So we had remote lectures and remote application classes. The tool that we have been using for the lectures is this Microsoft Teams that we are using also now. What's going to happen in the next semester? It has not been completely organized yet, but the intention of the university is to have part of the lectures of the classes remoted and part of the classes in presence, so in lecture rooms. However, also the classes that will take place in a physical room in presence will be transmitted, will be streamed. Therefore, on the one hand, the university intends to go back to classes at least for a part of the hours allocated for any course, but there will be the possibility to follow everything from somewhere else. The lectures, by definition, because they will be remoted. The classes that are going to take place in a physical room will be streamed anyway. So I hope this answers the question. What is the geophysical equipment used in the program? This is a tough question for me because I am not involved in that module, but I know they use, for example, the GPR, the ground penetrating radar. They use fiber optics. they use these electric tools to measure the humidity content of soil. Now I don't remember the name of this instrument. There may be more, but in this moment nothing else comes to my mind. Sorry if I was not exhaustive, but this is quite a specific question on a module that is not mine. Other? This is another question that cannot be answered. Which software should we know better? Guys, if you talk about specific softwares, the number is huge. Because if you are talking about structural modeling, you have plenty of softwares for structural modeling. If you're talking about photogrammetry, you have plenty of specific softwares for that. If you are talking about hydrology and hydraulics, you have plenty of softwares for that. So it's extremely difficult to provide an answer. What we typically do is that in any course there are some software packages used, mostly free. In case they are not free, the university provides a license, a student license. So as you know, sometimes it has reduced capabilities, but you can do what you're supposed to do. Anyway, training about these softwares is given during the courses, and therefore the students learn during the courses. If I have to mention a few, let's say, general purpose softwares, where general purpose means that they will be used in a number of courses. By sure, I would mention the MATLAB. It is taught in the course of numerical analysis, but then of course it will be used in any other course where some computation is needed. The GIS, and in particular, we most typically use the ArcGIS or the QGIS. After these, honestly, we move to the field of softwares that are specific discipline by discipline, and therefore the list is going to become long. Then there is another question: where can we find the lecture notes? Well, the first answer is you cannot, in the sense that the lecture notes of the program are uploaded on a system, on a platform that is called BIP. That is the platform of the Politecnico, and only the students of the Politecnico have access to it. On the other hand, there are two ways in which this can be fixed. The first one is that if a student is particularly interested in the lecture notes of one course, a request can be sent to the teacher of that course, and for example, access to this BIP platform can be granted also to other guys. Otherwise, on the website of the Politecnico di Milano, there is a section where you can look for any course taught at the university. You will be prompted a form. In this form, there is a description of the course, of its contents, and there is also a suggested bibliography. That is not exactly what will be taught during the course, but anyway is relevant to the course. So these are the ways in which study material can be accessed. Sorry, because the chat is moving fast and I don't want to miss questions. Career options. Career options are, on the one hand, similar to the typical career options of a civil engineer. They are for design firms, construction firms, sorry, agencies, engineering offices. We try to stress the fact that in addition to the general preparation of a civil engineer, the CERM graduates receives a specific preparation in this risk mitigation business, and therefore we typically mention also protection agencies, monitoring companies, and then what did I miss? Organizations, non-governative organizations that are focused on these aspects. The recent history says that, so let's make statistics of, it's not a statistics, of course, because it's just random examples, but I have in mind guys working for non-governative organizations. I have in mind guys working for mobility companies. I have in mind guys working for engineering firms. I have in mind guys working for small engineering professionals. I have in mind quite a lot of guys going on with their career with PhD. So the spectrum of possible careers is quite wide. The basis is the typical spectrum for a civil engineer, with obviously, because the program is devoted to that, a specific orientation to the risk aspects. Does the university provide us with the required software? Yes. Is ETABS software suitable for our field? I don't know what ETABS is, and therefore I don't know how to answer this question. If you want to be more specific, you can, but looks like I will not be able to answer this, sorry. Shall we know computer programming? The computer science abilities helps us. Let's say yes, as long as any engineer should be able to write simple code. So in general, yes. Before I was mentioning the MATLAB. In the MATLAB is used in this course of numerical analysis on the first year, and probably also on the course of computational mechanics of the first year. I'm not sure of the second thing that I said. And at least for the course of numerical analysis, students are asked to write simple codes in MATLAB. The story is always the same. If a student is already able to do it, very good. If a student is not yet able to do it, she or he will learn. But this is by sure something that for this specific course would be useful. Then for the other courses, most typically the students use software packages that do the computations that are needed to solve any problem. Still, it may happen that you need that very specific computation that the software is not handling, and in this sense, the possibility to write a simple code to do it is beneficial, obviously. But really, guys, we are now talking about something like, do I need to know Excel? Yes. These tools are so generally used that of course they help. Okay. I see no other questions in the chat. I hope that I didn't miss anyone, and you are happy with the responses that they gave. Okay, if there are no other questions, now we consider that the meeting is over. I thank you for participating. I thank you for the interest in this program. And I hope to see you in our program in the future. Now I will remain online for a while, so if any other question comes, you can still write or ask it in voice. If not, anyway, thanks again, and whatever choice you will make, I wish you a successful choice to the master program. Thank you.